All right, today is section 11.2, and we are doing, there are two parts, 11.2a and 11.2b. You wouldn't know that for my PowerPoint, so there's quite a few slides today. All right, so let's start with x squared equals, when x equals 3. So if x squared, what do you think the square root of x squared is? X, right? We'd think, well, let's try with 3 and see if it works. So when I take 3 and I substitute it in, that becomes the square root of 9 is equal to 3. Is that a true statement? Mm-hmm. That works, right? Yeah. Okay, let's try it with a negative number. Same thing, x squared equals x. The square root of x squared equals x. You don't have to write this part. So if I substitute in, I end up with the square root of 9 is equal to negative 3. And what is the square root of 9? 3. Does this work? No. So with negative numbers, we have to kind of account for that because it works, but not for negative numbers. So let's try now. It works for all non-negatives. So now let's try this to help us account for our negatives. So if I have a negative and I'm using the square root of x squared equals the absolute value, let's see if it works with a negative. So I substitute in negative 3. And negative 3 squared is? 9. And the absolute value of negative 3 is? 3. Does it work? Yes. Yes. So that's how we can account for our negative numbers. Does that make sense? Yes or no? Mm-hmm. Yes. So let's follow the pattern. Ready? So when you can choose to write this, I would write this all down as we're going. So the square root of x squared is equal to, we said, the absolute value of x. That way we account for, if it's a negative number, we can deal with it because of the absolute value. If I have something like the square root of x to the third. Isn't this the same thing as this? Can I break this up and do this? Are you with me? And then we can really kind of separate it, right? X squared times the square root of x. What is the root of x squared? X. Well, in this case, we don't need the absolute value because if it's negative, there's still another negative left under here. So it handles the negative. Okay? It's only the absolute value when there's nothing else left to multiply it by. Okay? So this really equals, instead of x, the square root of x squared times rad x, it equals x times, this symbol right here is called a radical. So sometimes we say radical x or rad x. Isn't that easier to say rad x than the square root of x? Mm-hmm. So because the symbol it is called a radical. So it's x times rad x. Does that make sense? Almost sounds Gen X, but not really. Okay. So the next one, x to the fourth, what is the root? Right. Remember when I'm asking your root, I'm asking you what times itself equals x to the fourth, right? So it's x squared. It doesn't need the absolute value because I have two of them. If it's a negative number, negative 3 times negative 3 would be positive 9. The only reason why I need the absolute value here is because the result is an odd quantity. Does that make sense? It's x to the first. You guys with me? Okay, next one, x to the fifth. Here's what we're going to do. If it's not an even number, we're always going to go to the closest even underneath 5. So that would be x to the fourth times the square root of x. What's the square root of x to the fourth? X squared. X squared times rad x. You with me? X squared times rad x. Oops. So it was, how I got it was I did the square root of x to the fourth times the square root of x. So it's x squared rad x. You with me, Nicole? I'm actually feeling pretty good now that I took some Advil. Okay, next one. X to the third, X to the sixth.
X to the third.
The root of it is X to the third, but it's an odd result, so we need what?
To the closest even.
No, it is an even. X to the sixth.
X to the third, the absolute value of
Yes,
X to the third.
we need the absolute value of X to the third because the result is odd. So if I have 3 negatives, it still won't work. So we have to put that absolute value. So the rule is we put it when we use the absolute value when you pull the root out, it's an odd result. Does that make sense? Yes or no? Okay. Next one, X to the seventh. Fionn, where do you think I'd go? How would I break it down first?
Radical x to the sixth
Times.
Radical x.
Good. And the root of X to the sixth?
X to the third.
Good.
Times radical x.
Good. And that is it simplified. Now for you guys, I would show how you got there, but I'm just writing so I can keep going with the PowerPoint. Okay, next one, X to the eighth. How about Nicole, what would it be?
It would be the absolute value of X to the fourth.
Okay, I don't need absolute value because it's an even quantity. Remember, a negative times a negative makes a positive. So every 2, the negatives get canceled. So I don't need the absolute value there. Does that make sense? Okay, next one, X to the ninth. Try another one, Nicole. Break it down first.
It would be X to the eighth.
Times
The square root of X.
X to the first, rad X. And what's the root of X to the eighth?
X fourth.
X to the fourth times rad X. Do you understand? Okay, you ready for the next one, guys?
Yep.
If you can go ahead, go ahead. If you see the pattern. What is the next one? Eitan? Absolute value of X to the fifth because it's an odd result. Next one, X to the 11th. Chloe.
It'd be X to the 10th times X to the first.
Good, and that breaks down to?
X to the 5th and X to the 10th.
Good. Okay. X to the 12th. How about Max?
X to the 12th would be X to the 6th.
Yep. X to the 13th. How about Julia?
We would do X to the 10th.
No, closest even.
Oh, I thought you said down. X to the 14th.
No, closest even under is not 10.
To the 12th.
Yep. Times
X.
rad X.
Rather.
And how does that break down?
X to the 6th. And rather.
Good. So do you understand what you did the first time? You went too low. You go to the closest even. Because otherwise, so let me explain why this you can't go there. Because if I break down X to the 13th, the square root of X to the 13th, and if we break it down to X to the 10th times X to the 3rd, notice there's another perfect square in there. Does that make sense? That 3 is really made up of X squared times X. So you want to go closest even. Am I making sense? Yes or no? Okay.
Wait, Miss Yamashita.
Yeah?
For x to the 8th, why can't you do x? Oh wait, never mind.
It goes straight to an even quantity. So the point here is that Notice, when this is x, these are odd results, right? X to the first, x to the third, x to the fifth. Every time you pull the square root and it's an odd result, you put it in absolute value if there's nothing else attached to it. That's the only time we use the absolute value. You will be quizzed on when to use the absolute value. Do you understand? Okay, you want to try the next few? Pause the recording and see if you can do the next ones on your own. All right, so on the first one, what did you guys come up with? Raising a quiet hand? Okay, go Mike, I haven't heard from you. Good, the absolute value of x to the 7th. The next one, I'm going to break it down on top, but I'm going to put the simplified version. So how do I break it down? Go.
Well, I got x.
I don't want what you got. I want to know how to do it. I don't care if you can follow a pattern, because it's not going to come to you. So how do you do
X
it?
to the 14th
Good.
times radical x.
Times rad x.
And then x to the 14th breaks down to x to the 7th times rad x.
Yep. Okay. Number 16. Number 16. How about, go Brienne.
It's x to the 8th.
X to the 8th. Good. Number x. Next one, Jamie.
Be radical x to the 16th times radical x.
Which breaks down to?
X to the 8th times radical x.
Good. Right? X to the, rad x to the 18th. Chloe.
X to the 9th in absolute value.
Absolute value of x to the 9th. Next one. X to the 19th. Breaks down to Max.
It breaks down to x to the 18th times rad x.
And that simplifies to?
Applies to x to the 9th times rad x.
Good. Okay. Next one breaks down to, I want to hear from somebody having a Tony. What? What? X to the 10th power. Good. Next one, Isabel.
Would be 10.
I want the, how to break it down.
Oh, how to break it down? It would be x to the 20th
Times.
times rad x.
Yep. And that breaks down to?
10 to the, or x to the 10th power times rad x.
Good. Next one. Okay, and then x to the 22nd. Go.
Absolute value of x to the 11th.
Good. Gracie, next one.
Rad x to the rad x to the 22nd times rad x, which breaks down to x to the 11th times rad x.
Good. Next one. How about Fionn?
X to the 12th.
Good. Next one, Nicole.
I didn't understand.
What's the closest, Stephen?
X to the 24th.
I asked you a long time ago, do you have this? You kept saying yes, yes, yes. You don't wait till the last question, okay? So x to the 24th times what equals x to the 25th?
X to the rad.
Rad. X to what power?
Just x to the
Yeah,
first.
yeah, to the first power to make it 25. 24 and 1 is, now what's the square root of x to the 24th?
X to the 8th.
No. X to the 8th times x to the 8th equals x to the 24th? No. What times what equals x to the 24th? X to the what? Look, what times what equals x to the 22nd? X to the 11th times x to the 11th. X to the 10th times x to the 10th equals 20th. X to the 9th times x to the 9th equals x to the 18th. So what times it's x to the 12th, keep going, and then what's left?
The x rad.
Rad x. We say rad x. Radical x. Okay, you guys get it? Okay, moving on to the next one. Okay. Oops. Did we do this one? Yeah. Yeah, we did. Okay, so now, out of order. Okay, Noah, first one.
If you can do x to the 25th.
X,
Or radical x to the 25th?
no. It's not radical x to the 25th. Because radical is the square root sign. Once you take the square root, once you half it, you don't end up keeping the root sign.
Okay.
You'll be doing it
So
twice.
it's just x to the 25th?
But what?
It'd be an absolute value.
It's absolute value x to the 25th because it's an odd result. Next one, number 2. Okay, Chloe.
It'd be x to the 42nd.
Good. Next one, Nicole. Break it down. First.
X to the 100.
Uh-huh. And then times.
That is
Good. And what's the root of x to the 100th?
x to the 10.
No. X to the 10th times x to the 10th does not equal x to the 100th. What? X to the 42nd times x to the 42nd equals this. So what is this one?
50.
Yes. You're halving it. Because rules of exponents say that when we multiply like bases, we really just add the exponents. So you end up halving it when you're pulling the square root. Does that make sense? It's x to the 50th rad x. Okay, let's try it again. Nicole, what's the next one going to be?
X to the 100.
No. 103. Where are you going to go?
X to the 102.
X to the 102nd times.
Rad x.
Okay, what's the root of 102nd? Come on, Spoon. It's very close to this. What times itself equals 102? 60 times 60, 60 plus 60 equals 120. Look, 50 and 50 is 100. So this is only 2 more. 52 and 52 make 54. What times itself, 1 added to itself? You're very close. You said 52 and 52 equal 54. So what equals, equal 104. What equals 102? 57? Honey, it's mental math. 57, 57. 50 and 50 is 100. 7 and 7 is 14. What times itself equals 102? Okay, you've got 50 and 50 equal 100. You've tried 54 and 54. You've tried 60 and 60. Come on, Nicole, try. 51. X to the 51st power times rad x. Okay? You got to push a little bit harder and keep trying and not just sit there. Okay? You've got to push it through it when you don't see it. Okay, next one. We're going to keep going. Who wants to go to the next one? Gracie.
First you have to find the closest even, which is rad x to the 252nd times rad x.
Good.
And then the square root of x to the 252nd is x to
Oops.
the 126th times rad x.
Can anybody tell me the rule every time? Like when I go from here to here, what's happening? Here to here. What mathematically is happening? We're dividing by 2. That's it. Just dividing by 2. Okay, when you pull the root out, what is it? Not if it's a coefficient, but if it's an exponent, we're dividing by 2. So what would the next one be? Fionn?
Absolute value of x to the 241st.
Yep. Do you understand? Is everybody clear on that? Yep. Okay. All right. We talked about domains. Now we're going to talk about domain in for radicals. The domain for fractions was thou shalt not divide by 0. Okay, that's the big rule. You can't have, in a fraction, you cannot have your denominator equal a 0, right? Well, what is the big rule for radicals?
It can't be negative.
It can't be negative. So that means every single time x is going to have to be greater than or equal to 0. So in this first one, it's pretty easy. We say x is an element, because when it says state the domain, it's saying what is x allowed to be. It's not asking for restrictions. It's not asking for exclusions. It's what is x allowed to be. It can be an element of the reals, and specifically, it has to be greater than 0. X is greater than or equal to 0, because it can't have a negative under the radical, right? We can't have this. Right? Or even this. Because no number times itself will equal -4. Does everybody understand the idea of a root? Of what's under the radical?
Yeah.
So same thing's going to happen if I have something like this, x plus 4. Under the radical, we're going to just take what's underneath, write this down, and you're going to set it greater than or equal to 0. Then what? Subtract the 4. And so x is greater than or equal to -4. So x is such that x is an element of the reals, and x is greater than or equal to -4. Is everybody understanding that?
Yeah.
Meaning it can be -4, -3, -2, because -4 plus 4 equals 0. We can do the square root of 0. We can't do the square root of a negative. Okay, the next one, x is an element of the reals, and?
It's greater than or equal to 5.
Right, it's going to be greater than or equal to 5, because 5 would give me the 0. It can be 0, it can't be negative. Right? Okay, it might get a little bit more complex. Set what's under there equal to 0. 2x, divide both sides by 2, and what do you get? So x has to be greater than or equal to 0. Okay, it's getting more complicated. I set 5x minus 1 greater than or equal to 0. I always set what's under the radical to greater than or equal to 0. I add 1. I divide by 5. So x is an element of the reals, but x is greater than or equal to 1/5. Are there any questions so far? Okay. All right, I'm going to skip this for right now. We have a lot to do. Okay. So, what happens if we have these perfect square trinomials or binomials? So remember, when I'm doing x squared, I take the root of x squared, it equals absolute value of x, because it's an odd result. It's x to the first, right? You guys with me? Mm-hmm. So, when I'm taking the square root of the binomial, notice the binomial is really to the first power. Because what times itself equals n plus 1 squared? It's really to the first power. Do you understand that? So the binomial has to go into the absolute value. So, what would number 1 be? What would number 1 be? Chloe?
Absolute value of x minus 4.
Yep. Absolute value of x minus 4. Nicole, what would the next one be? Perfect. Okay. Absolute value of 2x plus 3. Try the next one, Nicole. The absolute value of y minus 5. Okay. Can I do anything under the radical on the next one? Because there's nothing I can pull out right now. Factor it. So, what multiplies to positive 9 but adds to negative 6? Oh, that will give us the absolute value of x minus 3 squared. I don't need to write x minus 3 times x minus 3. So then what would it equal?
The absolute value is 3.
Okay, try the last one, 5. Go. Step 1, what do we do? Brianne?
I factored it and
2.
I got it to m plus 5 squared.
The quantity of m, the square root of m plus 5 squared. Good.
And then I got m plus 5
Absolute value of m plus 5. Good. You guys good with that? All right, now we're on to our second part. Now, so far with a quadratic, the only way that you've known how to solve is using the zero product property. Well, today we're using the square root method. So it's pretty easy, especially now that you have the background. Whereas I could have easily taught it to you before, but you really needed the idea of what is, when I have the square root of x squared, what do we get?
Absolute value of x.
The absolute value of x. And that in and of itself, before this lesson, you know, the kids wanted to do it because they wanted to memorize it. Some kids figured out the square root method, but they really don't know why. But now you know that why does the square root of x squared equal x? Because it's an odd result, right? So if I root both sides, right? Take the square root of both sides. Use my property of equality. You guys with me? What's the absolute value of x? So x squared, sorry. Square root of, sorry. What's the square root of, what's the square root of x squared? And the square root of 9 is 3. Now, to lose what that means is that absolute value. That means that you have two potential answers, a negative or a positive, right? So to lose it, you set x is equal to positive or negative 3. Therein gives you the two answers. So I had some people that were figuring this out, but they were still only giving me one answer. And that's because they didn't have the piece of the pie that said this. They didn't know, sorry, hold on. They didn't understand the idea that when you take the square root of x squared equals the absolute value of x. And to lose an absolute value, that means we have to account for the positive and the negative. You guys with me? And I want you to do all of these steps every time you solve. Because here you're showing me properties of equality. Here you're showing me that potentially there's two solutions. Here is where you simplify it down. Does that make sense? Okay. All right. So what would I do first? What do I do first to solve? I'm going to root both, right? I say x squared is the square root of x squared is equal to the square root of 36. Okay, now what? Absolute value of x equals 6, yes. To lose the absolute value, what do we say? Perfect. Okay. Next one. Want to pause it and try number 2 on your own. Okay, what do I do first? How about Maddie?
You do the rad of x of n squared equals the rad of 169.
Good. We root both sides. So rad n squared equals rad 169. Okay, what would I do next?
Then you say the absolute value of n
Equals.
13.
Good. And then?
And then you do n equals positive or negative 13.
Good. Okay, questions? I want to see all those steps. Next one. Y squared. What do I do to both sides? Root both sides. Don't be rude, just root it. That's what Mr. Gilliam says. He's famous. He's a teacher that used to work here. Don't be rude, just root it. So what would it end up being?
The absolute value of y.
absolute value of y equals, now watch this. I'm taking the absolute value of y, but I'm not taking the square root of 7. That's the beauty here, is this is far more accurate than you estimating. And in math, mathematicians do not like you estimating. So we leave it as simplified as we can under the radical. Okay, to lose the absolute value, what do I have to say?
Y equals positive
Plus or minus rad 7.
rad 7.
Isn't that nice? Yes, we're so happy. Okay, before you can use the square root method, you have to get the quadratic alone. So what do you think we have to do?
Add 6 to both sides.
Right, we're adding 6 to both sides. And then we get m squared equals 13. We're going to root both sides, and we get?
Absolute value of m equals rad 13.
And then to lose the absolute value?
M equals positive or negative rad 13.
Yes. Okay, next. We got to get the y squared all alone. What would I do? We're going to add 20 to both sides. And then we're going to divide by 3. And then then what would I do? Root both sides. Don't be rude, just root it. And then we get?
The absolute value of y equals 4.
And then we get?
Y equals positive or negative.
How are you guys doing? Okay, pause the recording and try number 6. What do I do first? Julia?
You would add 16 to both sides.
Adding 16 to both sides. Then?
You would divide by 2 on both sides.
Okay. And then we get?
X squared equals 10.
And then?
You would do the rad of x squared equals
We root both sides. And we get?
and the absolute value of x equals the rad of 10.
Yep. We don't even have to find the square root of 10. It's already simplified. And then?
And then you do x equals plus or minus rad 10.
Yep. Okay, did you guys get that? All right, so we're still doing the same thing. Subtracting 30. Divide by 2. Now what? Root both sides. I'm rooting both sides. And then what?
Absolute value of y equals rad.
Keep going.
Y equals plus or minus rad negative 7.
Agree?
Yes.
What's wrong?
Wouldn't this be y equals square root of negative 7?
Or not a real solution.
Why are you saying that?
Because there's a negative inside of the radical.
We can't, it's going to say no solution because you can't take the square root of a negative. You should have known, right? As I'm doing this.
No solution.
Okay. All right, next. I'm subtracting 2, right? And then we divide by 5. We're going to root both sides. And we get the absolute value of x equals rad 5. X equals plus or minus rad 5. You understanding this?
Yeah.
Okay, now, remember what I taught you about the radicals? I mean, about the binomials under the radical? I'm still going to do the same thing. Take the square root, take the square root, take the square root. Let's just do the 1. What am I doing? Jumping over here. Okay, so what is the square root of the binomial y plus 1 squared?
Y plus 1.
Absolute value of
The absolute value of y plus 1 equals what? 4. 4. Now, to lose the absolute value equals plus or minus 4. I subtract 1 from both sides. I get 1 equals negative 1 plus or minus 4. So that's 2 potential situations. Negative 1 plus 4. plus 4 and negative 1 minus 4. So the first one is 3, or, so y equals 3, or, let's see how they do it, negative 5. I did it just like that. Okay, questions? And you're saying y equals, really, in your answer column, you're saying y equals 3 or negative 5. Okay, pause the recording, try the next one on your own. What do I do? Who wants to do this one? Okay, Fiona, nice and loud.
The square root, you root both sides, and then the square root is absolute value of x minus 3 equals 5. And then it's x minus 3 equals positive or negative 5. You add 3, x is equal to 3, positive or negative 5. And then you get two different answers.
And they are?
3 plus 5
Is
or 3 minus 5, which is 8 and negative 2.
perfect. And so, questions there? Okay, forget about the height of a falling object. I'm going to stop right there. And that is the lesson for today.